Today we're going to talk about hypothesis testing. In the first two videos for these sections, we're going to talk about our 4 different steps for a hypothesis test. And then the last video for section 8.2, we're going to talk about putting all of these steps together to go through our entire hypothesis testing process. So in chapter 7, we learned about using statistics to make estimations about population parameters. When we're making these types of estimations, oftentimes decisions must be made using these estimations. So in this chapter, we're going to talk about hypothesis testing. So it's a method for making these decisions while controlling the probability of making certain types of mistakes, which we'll discuss a little more in detail in section 8.3. Okay, so to start with, let's talk about what our hypothesis testing is. Right, so hypothesis testing is a procedure that enables us to choose between 2 claims when we have variability in our measurements. So as we're going through our process, our first step is going to be to actually come up with a pair of hypotheses. So a null and alternative hypothesis for our test involving our population proportion, and then we're going to do some computations and interpret these results of our test. So we do have a formal 4-step procedure for these types of tests. So our first step is going to be to hypothesize. So when we're working through this first step, we're going to start by stating a hypothesis or claim that will be weighed against a neutral skeptical claim. As we're using and as we're writing these different pairs of hypotheses, we're going to use our equal to symbol, we're going to use our less than or equal to, greater than or equal to, not equal to symbols, similar to some other stuff that we did in previous chapters. Once we've stated our hypotheses, we're going to prepare, make sure that we have enough information to actually go through this process. So our conditions that we saw in chapter 7 are going to come back into play in the second step. Then our third step is going to be to actually do some computations. So we're going to have a different formula for z-values than we had before, and we're going to do some computations for that, and we're also going to use StatCrunch to make some of our computations. And then kind of the big end result of this process is going to be to interpret our conclusion. Do we believe our claim, or is there not enough evidence to back that claim up? All right, so to start with, we're going to focus on our first step. We're going to focus on our step where we come up with our pair of hypotheses. Right. So our first step, we're coming up with this pair of hypotheses. We're going to have a null and alternative hypothesis. So our hypotheses are always going to exist in pairs. And then from there, we're going to go through and test our claim. Right. So Merriam-Webster's dictionary defines a hypothesis as a tentative claim made in order to draw out and test its logical or empirical consequences. So our hypothesis that we're coming up with is a claim that we want to test. Right. We're not going to just have one hypothesis, we're going to have a pair. Right. So we are going to have a null hypothesis and an alternative hypothesis. Excuse me. As we're going through a process, the null hypothesis always gets the benefit of the doubt. We only reject the null hypothesis if the observed outcome is extremely unusual. So as we're going through these, our null hypothesis we're going to see is always going to have the same symbol, and we're always going to give it the benefit of doubt, assume it's true unless we have proved otherwise. A good analogy for thinking about our hypotheses is the difference between being proven guilty and or being found not guilty. So there's kind of a whole analogy as far as have we proved that something is true, or have we do not have enough evidence to prove that something is true. So there's a definite kind of relationship between those ideas in our findings of a trial and jury as there are in our hypotheses tests. Right. Our hypotheses are always about population parameters. They're never about sample statistics. So as we're going through these hypotheses, these claims that we're testing are about our population parameters. All right, so our hypotheses, as I've already mentioned, they come in pairs. So our null hypothesis is our H naught, or our H with a subscript of 0. It is our neutral, it is our status quo, It is the statement that is getting the benefit of the doubt, that we are assuming it's true unless we prove otherwise. Our null hypothesis always has an equal sign in our statement. Our alternative hypothesis, HA, we generally call it, or H sub A, we have a little subscript of an A there, it's our research hypothesis. It is the one that we want to, the claim that we're looking at that we want to test something about. Our alternative hypothesis cannot contain an equal sign since our null hypothesis does. So it contains a greater than, less than. We can use greater than or equal to or less than or equal to pretty much interchangeably, or a not equal to sign. So when we're looking at our pairs of hypotheses, we have two-sided tests or one-sided tests. So there's three different possible options that we could run into as we're working through these problems. So our two-sided test, our null hypothesis has an equal sign, our alternative hypothesis has a not equal to sign. So we are testing to see if something has been changed. Both of our one-sided tests, notice that we have a less than and a greater than. Our null hypothesis is still the same regardless of what type of test we're looking at. So in every single case, our null hypothesis has an equal sign. If it's two-sided, our alternative hypothesis has a not equal to sign, or if it's one-sided, we have a less than or greater than symbol. So our sign actually in that alternative hypothesis determines whether it is a one-sided or a two-sided hypothesis test. All right, so in our first example here, we're just going to look a little more closely at our pairs of hypotheses for our hypothesis testing process. So historically, about 70% of all U.S. adults are married. A sociologist who believes that marriage rates in the U.S. have declined will take a random sample of U.S. adults and record whether or not they are married. All right, so our null hypothesis. We're always going to use H sub 0 for our null hypothesis. And our null hypothesis is going to be that P, our proportion for our population, is equal to 0.70. So we're going to put the number from our historical information in there. Right? Our null hypothesis, meaning that these are equal, if we translate that into English, we're going to say the same proportion of adults are married now as in the past. Right? So our null hypothesis again has an equal sign. It means that nothing has changed, that we have lack of evidence to prove that something has changed. Our alternative hypothesis has to do with our researcher's claim. Right? In this case, our sociologist believes that the marriage rates in the U.S. have declined. So our alternative hypothesis is going to be our H with a subscript of A, our HA. All right, and since it's declined, we're going to use a less than sign. So we're going to use P is less than 0.70. All right, so the claim that we are testing is that the proportion of Americans who are married now is less than it was in the past. So as we're working through the rest of the problems in this chapter, we're not necessarily going to have to write out our hypotheses in words, but we do need to have an understanding of what they mean. But our first step in every single problem for this chapter is going to be to write out our pair of hypotheses using symbols. So again, our null hypothesis is the H naught, the H with the subscript is 0. It's always going to have a P equal to a number. And then our alternative hypothesis, our HA, is going to be P either less than, greater than, or not equal to, depending on the problem. In this case, we're thinking about it being a declining amount, so that's why we choose the less than symbol. So very similarly to problems that we did in Chapter 6 and Chapter 7, we definitely want to pay attention to the keywords that are telling us either less than, greater than, or not equal to for these problems. All right, for example 2 in this section, during the previous fiscal year, 30% of retailer sales were due to online sales. In an effort to increase this percentage, the retailer has purchased ads on social media sites. The retailer gathers data on types of sales on a sample of 20 days during the current fiscal year. Has there been a change in online sales? Right, so we're not going to write our pair of hypotheses necessarily in words this time. We're going to kind of focus on what they mean in symbols. Right, so our null hypothesis, our H naught, is going to be that P equals 30%. Right? If we wanted to write it in words, we could say the proportion of online sales are the same now as in the past. Again, it's not necessarily going to be required for a lot of these problems that we write it in words, but there are a couple of homework examples that kind of ask you to think through this process, so we'll go ahead and write these out as well. All right, then in this particular problem, it says, has there been a change in online sales? So if we see the word change or difference or something along those lines, we're not necessarily told if something has increased or decreased. So that means in this case, our alternative hypothesis, right, we can't put in greater than or less than because we don't know specifically if we're looking at the fact that it increased or decreased. So if we just see a word such as changed, that's when we're going to use our not equal to sign. Right? So we're going to say that P is not equal to 0.30. It's not equal to our 30%. So again, if we were to translate this into words, the proportion of online sales is different now than in the past. So again, we're paying very careful attention as we're coming up with our sets of hypotheses as far as what symbol we want to use. We're just asked, is there a change? We're not specifically told increase or decrease, so we're just going to use our not equal to sign. Since we have a not equal to sign, this is an example of a two-sided hypothesis. Right, so two-sided are not equal to. If we have a greater than or less than, that is our one-sided hypothesis. Right. So what other types of hypotheses could the retailer have posed? Right. So in this case, both of the other types are going to be our one-sided. Right. So they could have asked, have online sales increased? Or have online sales decreased? So instead of just using the word change, we could be specific about increase or decrease. Right? If it's increased, right, our null hypothesis is still the same. It's still that P equals 0.30. But if we were testing to see if it was increased, our alternative hypothesis would be that P is greater than 0.30. Have online sales decreased? Our null hypothesis is still P equals 0.30. Right? Our null hypothesis always has the equal sign. But if we're asked if it's decreased, right, then we're going to change this to a less than symbol. Right? So as we saw again in Chapter 6 and Chapter 7, paying attention to context words is definitely going to be key as we're going through these examples. So our second step of our hypothesis testing process is that we're going to want to prepare to work through our hypothesis test. Right? So we're going to identify our significance level, which is the first thing that we're going to talk about, and then we're going to state and check conditions that are required for future computations and state any assumptions that must be made. All right, so let's first talk about this new term of significance level. Right? As we're doing any sort of statistical analysis, mistakes happen. Right? So mistakes are often part of our hypothesis testing process. We do not want to make them too often. We have a couple of different types of mistakes that can occur. In this particular case, for our significance level, we're going to focus on one particular type of mistake that happens when we reject our null hypothesis when it was true. Right? We can't prevent it from happening entirely, but we can try to minimize the effects of this. So what we're going to use is something called our significance level. So our significance level, we're going to use the Greek letter of alpha to represent. Right? So our significance level is the probability of making the mistake of rejecting the null hypothesis when in fact our null hypothesis is actually true. In section 8.3, we're going to kind of further explore different types of mistakes. One of them is going to be tied to our significance level. One of them is going to be another type of mistake that could possibly result. Right, so again, it's represented by the Greek letter alpha. For most applications, we'd like to use 5%, a significance level of 5%, kind of like we used a confidence level of 95% in the previous chapter. So the 5%, 95% tend to be a pretty good range. Sometimes we use 1% or 10%, and notice in all of these cases we're looking at these and we're looking at our significance levels as decimals. All right, so in example 3, we're looking back at our first example where we stated two hypotheses about our proportion of U.S. adults that are married. Right? Recall that in the past the proportion of U.S. adults that were married was 70%, and the sociologist believes the marriage rates in the U.S. have declined. The researcher intends to test these hypotheses with the significance level of 5%. All right, so our significance level, again, we're always going to use the Greek letter alpha to represent, and we're always going to write it as a decimal. So we're going to write alpha equals 0.05. All right, so what does this mean? This means that this is the probability of rejecting our null hypothesis when in fact it is true. Right, so we're going to say in this context, right, this means the probability is 5% that the company will, so if they reject the null hypothesis, they're going to say that it has changed. So that the company will conclude that the proportion of adults who are married is smaller than 70%, which means we are rejecting our null hypothesis, right, when it is actually 70%. Right? So when our null hypothesis is true. So our significance level gives us the probability of rejecting our null hypothesis when it is true. All right, the other step in our preparation, our second step for hypotheses test, is going to be to check our conditions that we have seen again in previous chapters to make sure that these conditions hold for our particular examples. So our sample must be random and independent. So again, we're going to assume that this is true unless we are specifically told otherwise. We need a large enough sample, so at least 10 successes and 10 failures, right? And at least 10 times population size that's at least 10 times larger than our sample size. Notice that as we're looking at these calculations, these do have a p sub 0. So as we're doing these calculations, we're using our p sub 0, which is our original percent in our problem. So in example 4, we're going to look at and go through our process to check our conditions. So does ownership of an e-reader increase after the holidays? A publisher believes that in early December 2011, about 10% of Americans owned an e-reader. In January 2012, the Pew Research Center conducted a survey of 1,377 randomly selected adults and found that 19% of them owned an e-reader. Can the publisher conclude that the e-reader ownership increased over the holidays? Right? So as we're going through all these problems and as we continue to go through ones in the next section, we're going to use see a p sub 0 and we're going to see a p hat. So our p sub 0 is our original percent. Right? So the sub 0 is our original value. So that means in this particular example, this 10% is going to be our p sub 0. So that means looking at our calculations, that's the number that we're going to plug in. As we go forth into the next section and we're actually talking about our hypothesis test, the other percent that's mentioned in our problem, so in this case the 19%, that's going to turn out to be our p hat value. And so we'll just kind of mention it now because it is going to show up again in the future. But when we're using and checking our conditions, we want to make sure we use our p sub 0, our p naught, our original percent that we're looking at. All right, so we're going to check our conditions to show that the test statistic for the e-reader survey approximately follows a standard normal distribution. So the sample is random and independent. We are going to assume that is true unless we are told otherwise. Right, do we have a large enough sample? So we're going to take our sample size, our 1,377, and multiply it by our p naught, our 10%, so times 0.10. That gives us 137.7, which rounds up to 138. 138 is clearly greater than or equal to 10, so we're good. Then we're going to take our 1,377 times 1 minus 0.10. Again, we're going to round it off to the nearest whole number, and we get 1,239. Also greater than or equal to 10. So our conditions have been satisfied. As far as checking our large population, right, our population in this case would be all U.S. adults. And if we take 10 times 1,377, we get 13,770. I mean, even if we were looking at a smaller group of adults in the United States, our population would clearly be big enough. So our second condition, we're going to think about our significance level, and we are going to check our conditions if required. In a lot of the examples that we're going to work through in class, we're going to skip the condition part, just simply for the fact that we've gone through it a lot of times in a lot of other examples, and at this point, hopefully you should feel comfortable with that process.